Welcome everyone to the second session for the app dev stream at the virtual GSE. The session is being recorded, and for GSE members, you'll be able to watch the recording on Vimeo at some point in the near future. This session is Zowe and Zero Trust Architecture. And Jakob has spoken many times before at GSE, so thank you for contributing again. If you have any questions, please type them in the chat. I'll be monitoring it. Jakob's happy to take those questions as and when they crop up, so I'll interrupt him and ask the question. And obviously, if there's anything at the end that you want to ask when he's got to the end of the material, that's fine. So I will say no more, hand it over to you, Jakob. Good luck.
Okay, hello everyone, welcome. And my name is Jakub Balhar. I'm a principal product owner at Broadcom. I'm also the chair of Zowe. So if you are unhappy about Zowe, let me know. If you are happy, you can let me know as well. And let's dive into the Zero Trust architecture, what it is, how do you start about implementing it in your company, and what exact role Zowe and its components play in the whole architecture. So first, what is actually Zero Trust architecture? So there are some changes that are happening across the last 10 to 15 years. Most of the people that I've worked with in mainframe space, but quite often also in the distributed space, are used to having like a perimeter that they can defend. So having like internal networks and making sure that all the people that are connecting are in location, in office location, stuff like this. With the movements to the hybrid and remote and more flexible arrangements, this is not the case anymore. And so we need to find out a good way to work with it and a good way to defend the assets that are valuable. The two main acronyms that are linked to this topic is IoT, so Internet of Things, the amount of different sensors and automated tools and automated machines that are being used are one of the sources for the potential problems and risks within the current environment. And the other is bring your own device, meaning that the employees can bring their own devices and connect from their own devices that are not under full control of the corporate into the corporate networks and access at least some of the corporate assets. One of the first things that you need to keep in mind in this changed paradigm is that you should never trust and you should always verify. Just because somebody is connecting from the office location, it doesn't mean anything. And it shouldn't mean anything. It just means that you still need to authenticate, you still need to verify and potentially do some kind of more complex authorization by accessing the important and relevant assets and resources. One of the key things that's relevant is the mutual authentication. So not just that the client is verifying that it's connected to the correct server or service, e.g., you really want to make sure that when you are accessing your bank, it's really your bank and not just some phishing attempt, but also the other way around. So when the service is being accessed and used by the client, the service also needs to verify whether the client is there. And it needs to verify some more information about it. So one of them is the identity, what exactly so who exactly is the either user or service accessing. Health, so whether it's in a good state, so limiting the risk of being exposed by, for example, some virus that's residing on the machine. As part of the discussion on the confidence, the users users should use the multi-factor authentication to limit the possibility to just steal the password or get the password through other sources and then directly use it to access the assets. One of the other more important areas are the visibility and the analytics. So when you are trying to figure out whether it's okay to let user or service access a specific asset, you should have very good visibility over your network. That means overall network, so all the distributed sites as well as on all the mainframe side. And you should be able to use this data as part of the analytics to decide what is the proper level of the authentication and authorization for the specific user to access these assets. Continuous authorization is part of the topic, and it's talking about making sure that it's not enough to grant the access once in case the importance and or complexity of the assets that the user is trying to access is higher than what he was currently or she was currently accessing. There are few things that the zero trust architecture expects that to be true, and that are important parts of why it was built and how it was built. So the first of them is that the network is always hostile. There is always someone out there who is after you and your data, because the data are valuable and you can sell them. The threats are there all the time. They are changing in time. They are most probably getting worse, but on the other hand, you are also getting better at defending. The identity theft is relatively common, and the phishing and spearfish attacks. So you have to be very careful about trusting the claims about who is someone. Just because they have one valid JAT token doesn't necessarily mean that they are who they claim to be. And while it may be okay for them to access something that's a low risk, maybe it's not really great if they can access your production database and actually change something just with this. And another thing that was learned through trial and error is that the static policies are not good enough. So if you really want to make sure that your environment will be fully secure, it's not just like every 2 months we will do a review and change a policy, but the policy need to adapt based on the patterns that it knows about the specific user, specific services, and specific usage. So the policies needs to be dynamic and adapting to the actual environment they are living in. There are few pieces to the zero trust architecture that are always, or at least usually, part of it, and that's within the control plane and data plane. In the data plane is a policy enforcement point. Basically, whenever you try to access any resource, any asset that could be valuable, you go through the policy enforcement point. Policy enforcement point is a single point of access, ideally, or multiple points of access that consult this policy enforcement point, that verifies, okay, is this the user who the user claims to be? Does this user have the access? Should the user have the access? Do we need more information and possible further authorization to get the access? And to be able to do this, the data plane and the policy enforcement point communicates with the control plane. So control plane consists of 2 main parts. One of them is the policy engine, and one of them is the policy administrator. So policy engine is the place where the policies that are actually applied are being partially prepared by administrators and partially generated based on the previous data and the previous information. Policy administrator is and should be a person that actually handles overview over this policy engine, taking a look at what's going on and what's changing there, and potentially adding and changing some of the policies within the engine necessary to access the resources. In order to do this well, we are depending on many different sources of data. I would say as much as we possibly can. So we have, you can see them on the sides on this slide. So it's information from the CDM systems, from the industry compliance, from threat intelligence, activity logs. So anything you have running in your service should be source of the data for whether somebody should access it and in what level. Data access policies, public key infrastructure, so your certificate, the way you manage them, stuff like this, identity management, and your CM system. So what do you need in order to support the zero trust architecture in your company? First, there are people and companies out there that are more expert and can help you more with this, but I will do some intro in what you should know at the very least and where you can start if you are uncertain. First, all the relevant assets that should be accessed by anyone via any kind of network needs to be connected to network that can consult the policy enforcement point. So all the assets that needs to be accessed and that are valuable needs to be accessible, needs to have access to the policy enforcement point to verify whether the users are the ones that should be accessing them. Second thing, and part of it is if you have some remote assets, like for example, in a different data centers or in different offices, then it doesn't require the enterprise network. It should work over the public networks, as you can't anyway guarantee that the enterprise network won't be breached, and you are probably just living in a false sense of security. You need to have a good observation setup. So this is about collecting all the data from all the possible sources and being able to use them effectively. Most probably you already have something. Usually you will have one or multiple places that will collect the data, and then one place to look at the results, and that one place, something like Kafka, that will help you feed all the data that you collected from the system into the policy enforcement point in some way. As for the policy enforcement point, already mentioned, all assets has to have access, and all accesses are consulted with these policy enforcement points. One important part here is that policy administrators are accessed only by the policy enforcement points or by living people. You shouldn't allow access via some kind of service-specific tokens to the policy administrators, as it's quite dangerous. So, as with any type of architecture and any type of approach to solving security problems, there are associated risks. These are the ones that are, I would say, well known, but we will go over them. So first, if one of the problems if you can't access the policy enforcement point, and one of the ways how you can attack is, for example, via the DDoS attack, distributed denial of service. And as a part of this, it means that you could have limited visibility into the network. And so, for example, you may be thinking that you are consulting the policy enforcement point, but the real one is down, and you are actually consulting some different policy enforcement point that was provided by the attacker. One of the obvious problems is if the attacker takes over the decision process, which means that they are able to either change the policies or change the policy administrators, or they at the very least get access to the policies themselves. And if they know how the policy engine works fully, then they can devise an attack that would be passing through the way the policy engine works. Like, I would say that lots of them are done very well, but it's software, so there are bugs in it. And the more the attackers know, the easier it's usually for them to figure out some solution. I already mentioned that a big problem is if the non-person entities are used in the ZTA administration, it's usually easier to just steal token than actually cut off somebody's thumb and get access through the biometrics and effective multi-factor authentication. But still, it's something that I've seen before done. And one of the problems for the overall zero trust architecture that lots of us will be facing in the coming years until we figure it out, hopefully somehow effectively, is that each vendor and each solution that claims to do all the things does just the part and does it in their specific ways and have proprietary data formats. They are not supporting interoperability between them. And so yeah, so it's easy to get into a vendor lock-in situation that's not really effective because the vendor doesn't support everything you actually need to handle. So we've been through what the ZTA and Zero Trust architecture stands for and how it looks like approximately. The next step is how do you approach it? If you already started with Zero Trust architecture, if you already have started with something, then there will be probably nothing new in this section for you. But if you didn't, then maybe this will help you at least a bit. So the first step that you need to take a look at is where actually are you and understand the landscape of what services you have in your organization, how are these services used, and who are the actual users that should use them. And after you've done this initial assessment, so you know, okay, we've got these 600 services. Out of them, there are 400 business facing. There is 100 infrastructure supporting the business and 100 infrastructure operating the operations. You have identified the groups of the users that should have the access to them. You've probably already done this before in the ESMs, so you probably already have most of this information somewhere in the ESMs. So it's most probably just getting it out of there, at least some pieces, and integrate it in the policy engines properly. And the last part is to figure out what infrastructure do you want either already have accessible within the enterprise to collect the data from the observability and potentially feed it then back to the policy engine and policy enforcement points, or what infrastructure you need to get in order to do this. I would say that if you are coming from large enterprises, you can very easily have billions of transactions that you need to handle through this observability infrastructure. So you need to make sure that it's ready to handle the whole traffic that you are interested in. The first key part for you are the services. So who are the services users? So ideally, you identify the groups of users that have access to the specific subset of the services. And for each service that accesses some kind of data or processes them, you should start having an understanding of what data the service processes, what's the risks associated with stealing this data, and who and why should access this data. This is the first part of understanding your service landscape. It should help you also in when you will be adding new services. For example, you will decide that Zowe is the way you want to go, and you will start depending on it and adding the conformant extensions. Then at this point, it should be easy for you to add these new services into one of the groups and making sure that the appropriate users and appropriate groups has access to them. For the authentication, there are a few things that you should make sure that you have. One of them, and I would say among the most important, is multi-factor authentication. Make sure that it's not possible to access the key assets by only using username and password. If you use the multi-factor authentication, most probably you will start with some kind of static authentication. So like always, every time you will just ask for the specific factor, for example, by using your finger or getting the SMS. Or you can move to more dynamic, which is probably going to come a bit later, when based on the information the system overall have about the whole service, you will be able to say, okay, in this case, it's enough for me to use the fingerprint, or in this case, I really want to know again your password, I want to get your fingerprint, and I want your eye scanned. Really depends just on how difficult and how important it is for you to keep the data safe. Another thing is a single sign-on. In general, if you are able to integrate all your services into one single sign-on solution, it means that the users will have just one password ideally, and not 20 of them. And with this, it should be easier for you to make sure that the passwords are good, actually, that the users are not forgetting them too often, and that they are not giving these passwords to anyone else. One note with this, please, unless you really have to, don't require changing the passwords. There were already studies by NIST and other bodies that it's not really effective. The quality of the passwords is decreasing as this is mandated, and ultimately it's actually decreasing the security of this whole solution. For the authorization, again, so how do you approach it is you're gradually adding additional layers. Usually we'll just start with consulting the ESM, whether the specific user has authority for the specific resource. But later on, you can add some other functionalities and other layers like step-up authorization, making sure that in specific cases, it's necessary to provide multiple ways for authentication. And again, we are gradually moving toward dynamic policies where the data that we are observing, the information about the user, are gradually becoming a part of how you decide on what is important and what is necessary and what is safe, actually. Now let's move on to monitoring. It's one of the key parts because basically, let's face it, most probably most of your organizations has been at least somewhat breached. And most probably organization I work for has been breached. The point here is to make sure that we are certain about this as soon as possible, that we limit the impact, and that we prevent the attacker from gaining access to at least the key data. Important part is in monitoring and making sure that you are well aware of everything that's happening within your network and organization. As for the current state on the mainframe, most of the applications are generating the SMF records either directly via system, or they are generating their own SMF calls that can be then processed and handled in the tools like SysView and others. And this is a good start, definitely. But one of the problems that we are facing is that the next step is to make sure that we can integrate with the distributed infrastructure, as at least some amount of business is also happening there. And we need to make sure that that as an enterprise, we don't have to have two different solutions for each of these. So we need to figure out a way how to integrate. And we need to use the data from the mainframe as well as the source. For the authentication requirements, we can't depend just on the data from distributed. I will talk about this more when I will be touching how exactly and what is available within Zowe. So now we've been through the zero trust on what it is, how you can start if you want to achieve it. And let's look a bit at one of the use cases that's well understood and was well documented. So once we are after this session, if you want to get even deeper dive than what I will be covering here, it's possible to really go into, I think it's like a 10-page or 15-page explanation of what exactly happened in the Stack Overflow. And Stack Overflow was partially breached in May 2019. And they very well explained what exactly was happening, what were the problems that faced. And I will be touching this from the point of view of the zero trust architecture and what specific points or specific pieces it could have prevented. It's possible that it wouldn't prevent the whole attack, but it could have make sure that it's visible faster. Though I must admit, Stack Overflow did find about the attack before the attacker actually reached anything really valuable. And they were able to monitor what's going on and at some point stop the attacker. So it didn't really end that terrible compared to plenty of other breaches where the customer's data were actually stolen. So for the Stack Overflow, the attack vector was that the attacker was going through the dev infrastructure. So basically, the attacker got access to one of the developers' machines. I don't mean like a notebook or laptop, but one of the virtual machines where the development environment was running. And with this was able to gradually, after exploring some stuff, elevate the role from just like user on the specific infrastructure to the content manager. That gave him access to some more functionalities of the Stack Overflow. One of the important one that was forgotten on their dev environment was that it was possible to use a specific endpoint to elevate your privileges. So basically from the content manager, it was possible to get to the administrator. And with the administrator roles, he could continue further. It took him a few days, always it took like a few days before moving to the next step because he was exploring the environment and looking for the answers on how to do some different things on the Stack Overflow. So Stack Overflow was helping the attacker to attack Stack Overflow. Gradually, the attacker was getting access to more services within the development environment. One of the reasons, there are a few reasons why he was able to get that far. Some of them were about forgotten flags in the development environment that allow the user to get more privileges. Another one was thanks to the stolen tokens and so impersonating specific services instead of specific users, which gave him another access to some pieces. And as we can see, like at least these two parts would have been prevented very well if we were using more of the users and verifying that the multi-factor authentication is used. Gradually, he was stopped when he got the full access to the full development environment, all the code, and was able to start deploying some potentially harmful applications in their dev infrastructure. At that point, the attacker was stopped, and a few months after, Stack Overflow provided us with the full deep dive on what exactly happened. In the recent weeks, there was another very good report on the Circle CI and the attack that was on them. I don't have it in this presentation yet, but if you are interested in the topic, I also recommend this as a very good reading and learning material. So let's move on to Zowe and what role Zowe and specifically API mediation layer plays in this. I will be talking about Zowe on the server side mostly. So if you are interested only in the CLI and VS Code, it's tangential to some extent. They do use the API mediation layer for some functionality, and if you use it properly, then you will get all the benefits and all the functionality that I'm talking about, but you don't have to parse it, so it's up to you. So if you haven't seen Zowe before, I guess you did. Zowe is a relatively large project that's composed of multiple components. There are the client-side components like CLI, VS Code Explorer, and Zowe Chat. And then there are the backend side components that are actually installed on the ZOS, like the application framework or API mediation layer on the ZSS. Overall, it works like this. The client-side components are communicating via the SDKs that we have with the API mediation layer or ZOSMF or the other microservices, and then answers all the relevant parts. As for the client SDKs, we've got some amount of them. We've got a very mature Node.js one. We've got a Python SDK that's gradually maturing, and we've got a Kotlin SDK that's more or less matured now with IntelliJ, Explorer for IntelliJ. For the API mediation layer and its role within the architecture, the API mediation layer should be a single point of access. So ideally, all the services that you want to access from outside of the mainframe will be onboarded into the API mediation layer. It has multiple benefits. One of them is that from the outside, you have to defend just one port, and the services communicate just with the API mediation layer. Another one is the single sign-on, meaning that the API mediation layer can accept many different methods from the outside. So you can provide the client certificates, you can use the personal access tokens, or you can just use the regular chat tokens, and then exchange this for the method of authentication that the downstream or southbound services can understand. So you can involve your services in the SSO, including your own infrastructure APIs, without changing them and getting all the benefits like the client certificates with very limited amount of pain. And on top of that, there are plenty of conformance services coming from, I think it's like 5 companies right now. You can find a list of them on the Open Mainframe project website. So first, where does the API mediation layer fits in the Zero Trust architecture? There are 4 areas where there is some role for the API mediation layer. So first of them is authentication. The API mediation layer already handles authentication thanks to the fact that it supports the single sign-on for Zowe and potentially other services. As there is still no standard yet for the policy enforcement points, what's possible to do is to create an extension. We have a support for internal extensions to the API mediation layer, which can call the specific policy enforcement point via your own specific protocol, and then consult properly every authentication attempt. The same applies for the authorization. It's possible to get to a place where every request before it passes through will consult something else. Right now, we are usually consulting ESMs as part of the authentication, but once you have some specific policy enforcement paint service, it's possible to integrate it with mediation layer. Another area that's important is observation. It's possible to effectively propagate data from the API ML and assist the single point of access. It has lots of networking and traffic data that's relevant for all the observability architecture. And it's possible and relatively easy to get it into some already existing solutions, such as Kafka or Elk Stack or Splunk or something else that you are using. And the last area was in prevention of the DDoS attacks, at least somewhat preventing. And it has two parts. One of them is making sure that Zowe itself is highly available and the services that are part of it are highly available. And the second part is in making sure that the rate of access to the services is limited. So hopefully, if something bad happens, the API mediation there is the first step that's overloaded instead of your actual mainframe services. As for the authentication, every request should go through the API mediation layer, as it is already a single point of access. We are already verifying authentication, at least to some extent, on every request. It's possible to integrate with the policy enforcement points or other dynamic policy sources. Or if you feel like what you already have is becoming a standard, let us know, and maybe we can even integrate support for a specific protocol in the API mediation layer itself. We are now working and closing the possibility to integrate with the distributed identity source, such as Active Directory and Okta and others. And of course, right now, we are basically verifying in most of the setups, either directly with SAF or via Zowe SMF with SAF on per request basis. So for the authorization, there are a few areas where the API mediation layer can help you at least a bit with the authorization. So first of them is personal access tokens that were introduced in 2.3. It's basically a service token that you probably know from services like GitHub, where you specify the scope. In this case, scopes are specific services. It's not possible to wildcard, so you really have to know what specific services this token has to have access to. And then the API mediation layer won't let you access other services with this token. Identity federation, this is about linking to the distributed identity providers via OIDC and keeping in mind the information from and the access rights that are part of the OIDC providers. Apart from that, the last part are self-access checks. So if you need to do some verification on your distributed site against SAF, the API mediation layer provides an API to verify whether a specific user has specific access to the specific resource. Apart from that, we already do this for some of the endpoints that we consider more sensitive within Zowe. So that's part of it you can use. So let's move on to the observation. Why do you want the observation to be an important part of your strategy and approach to the zero trust and security? First thing is that you want to make sure that basically everyone that should have access to the information about the availability of the service to limit random calls and random asks, and also for them to be able to gauge whether if they are accessing service, whether it's actual service or whether it's just a fake one that was provided by attacker. This could help with this. It helps in finding the performance issues with the southbound services. So if you have a good observability strategy, you know very well on what exactly the specific requests looked like, how long they take, where they did take the time, and what was going on in general. One of the key parts and key roles that needs to be done properly is the integration, because this is not about one service or one provider doing everything while integrating together, but it's about making sure that your infrastructure is easy to integrate with each other. Already mentioned things like Elk, Splunk, or Grafana. You can even integrate this data very well as a part with your SIEM, security, incident, and event management system. This will be mostly relevant for your security people on the distributed sites. So we already provide some solutions within Zowe for this, basically we do provide monitoring or metric service that's part of the open source as a technical preview. The monitoring service is basically a visualization tool that shows you information about the requests going through the API mediation layer and about some information coming from system via another tool that's part of Zowe, which is known Zebra. And apart from that, we have a proprietary extension that may become open source at some point in time, where we basically provide a simple integration with other toolings like Kafka and ElkStack. So within the monitoring or metric service, we first can take a look at the information about the usage of the CPU and services usage on the ZOS platform itself. The Zebra itself provides the JSONified records to use also potentially in other places. And as the second part, it provides the information about the amount of requests, how long they took, whether the circuit breaker was necessary to be used, and stuff like this. As for the audit log, it's an extension to the API mediation layer. It's possible to install it via the ZWE command line utility that's part of Zowe itself. It's sadly, as of now, available from Broadcom, but we are discussing figuring out maybe moving this at least somehow to open source. It provides information about all the requests and about all the configuration changes that are happening around the API mediation layer. This is just to show how it looks like integrated with the ElkStack. So this is the Kibana dashboard that shows all the accesses to a specific instance for a given time frame. There are few things that you can do with the audit log that may and are probably relevant for you. Like it's possible to look at all the authentication logins of the users against the API mediation layer. That's relatively easy to find. You can look for the anomalies, like the requests that are taking too long, or requests that are failing, or requests that are failing with a specific HTTP status. And it's easy to integrate if you already have some observability effort, because usually you're gonna be able to use Logstash and its all adapters to push it basically to anything. We are internally using it to push the data to Kafka. And then as one of the options, and another option, we are also feeding it into the Kibana and Elasticsearch to be able to work with the data. Here you can see how it looks like when you are looking at the Kibana dashboards for the types of the user requests and logins. So you can take a look at who was logging in, how many login requests were there, and how many user requests afterwards were done by the specific users. So it also helps you understand the patterns of the usage of all the services. As for the high availability, the main goal obviously is to prevent the downtime. And this means that two things. One of them is that when there is some problem with specific LPAR, it's not going to impact the whole system. Another is that if you want to upgrade the either specific service or the Zowe itself, it should be possible to do this without the downtime. So ideally, we would get to the 6/9 of the availability, or maybe even more. As for Zowe, so the high availability within the Zowe are twofold. One of them is that there is a HA setup of the Zowe itself, where there is a Dvipa as the coming element. There are multiple Zowe instances on different LPARs, and as long as at least one of these instances is alive, you will be able to properly serve the requests. The another one is the services that are onboarded on the Zowe. For each service, it's possible to have one or more instances of the service. And the API mediation layer handles the load balancing, handles the retries, and make sure that we are not trying to access the service in a degraded state. So basically, as long as there is at least one working instance for the service, it's gonna be properly processed. And On top of that, if the service is either down or has some problems just for a short time, it will be, thanks to the circuit breaker, left for a short time from the load balancing, and then after some time it will be back again, and the user doesn't even have to know that there was any problem. So all of these things that I was talking about are great, but they are useless if Zowe is not set in a correct way. So in the last part that I'll be talking about, I will be mentioning how do you want to set up the Zoes and APIML specifically in a way that makes it as secure as possible given the current knowledge. So first part of it is you should be using TLS. You should be ideally using TLS 1.3. We are already supporting it for quite a while. Here you have the specific cipher suits that we recommend that are going to be with us for quite a while. We recommend that you are using Java 8, at least SR6 FP25. You will have access to this presentation afterwards. So if you want to consult anything here, either these things are already documented in documentation, or you can just take a look at this presentation. In order to make sure that the certificates are stored securely, we definitely recommend using the soft key rings, as they are better secured and overall better than the PKCS12 files. Though Zowe does support PKCS12 files, but if you are aiming for production, I just don't recommend this. Within the Zowe, we have some automation and tooling to help with either generating new certificates or with importing the existing certificates into the soft keyring. So at least theoretically, it shouldn't be too much pain. Next part are the authentication tokens. This is about what's coming out from the north side. There are a few different ways. These first ones are the JAT tokens. The API mediation layer can issue JAT tokens that have validity. Either there are two different ways. One of them is when stuff is used directly by API mediation layer, and then it's a configuration of the API mediation layer to say how long these are valid. Or it's part of the Zowe SMF and WebSphere Liberty, where you can again configure how long the JAT token is valid. This token is available for the clients via the APIML authentication token cookie. It's also possible to use it via the authorization bearer. When you are calling the API mediation layer, it will process both of these correctly. Here on the slide, you can see how such encoded JAT looks like and how you can get some basic information from the token. The token has to be signed by the private key from either Zowe SMF or API mediation layer. So unless you lose the key, the users are not able to issue incorrect tokens and use them actually. Another authentication method that's supported by the API mediation layer from the northbound side is the client certificates. So ultimately, we would recommend to use client certificates as much as possible, but we also know that there is a lot of pain in actually managing and handling them. So there are other ways that we support, but if you can, having client certificate to authenticate is really effective and it's really secure. So you should definitely do this if you can. On the other hand, they are usually living for a year, and so you have to manage properly changing them in the right time frame so that the persons and the services has the right accesses. The good part is that if you have services that you want to use certificates, you can onboard them to the API mediation layer and let the API mediation layer handle this part for you. There are few important things around certificates that are either used directly by API mediation layer or that are to be used in authentication. So first, the certificate authority needs to be trusted by Zowe. And second, the extended key usage, which is an information that's part of the certificate, either has to be empty or it has to contain the information about the client authentication so that the certificate could be used for the client authentication. How exactly you can do this and what exactly it means is in the Zowe docs or just in general word out there. But basically it means that there is some specific type in the specific extended key usage when you create a certificate. And the client certificates that are used in the authentication for the specific user needs to be connected to a mainframe identity. So just because it's a valid client certificate, it won't let you do anything unless there is a user it's linked to. If the client certificates are too heavy and all the requirements on changing them and moving them around, making sure that different people has the valid certificates, we did introduce the personal access tokens. You probably know them from other services as well. Basically, it's a chat token that can live for a longer time frame. Usually it's not a year, but it could be even potentially as long as a year. The actual limitation on how long is the maximum is configurable by administrator. And this tokens gives you access just to a specific service or list of services that, for example, a specific DevOps pipeline needs and nothing else. And it's not linked to the user's credentials. So if the user needs to change the credential, the user doesn't necessarily have to change the personal access tokens and the other way around. As we know that there are some risks inherently associated with the existence of the tokens, it's easily possible to revoke the tokens for specific users or specific service. So if you find out or feel that there may have been some problem, you can just easily via one call invalidate all the services that can all the tokens that can access a specific service or all the tokens from a specific user. By default, it's disabled, but it's just one flag in the configuration. It's easy to enable. Another token that we support from both sides is the SAF-IDT. So this is a type of a token that was introduced by the ESMs in the last years, I think. It's a signed chat format that can be consumed effectively and well, hopefully by at some point most of the mainframe services. It's issued for the specific application ID and it's a list of application IDs, and the validity is up to 24 hours as of the current implementation. API mediation layer can validate these tokens as well as it can issue these tokens for the specific service. So if your mainframe service understands the SAF-IDT, that's what it can get. In general, Zowe and API mediation layer supports multi-factor authentication. We do support out-of-band multi-factor authentication, and it was tested for CAAM and IBM Z multi-factor authentication. If you want to use this, either you need to use SAF directly as authentication provider or ZOSMF as the authentication provider. And for ZOSMF, there are two things that need to be valid. First, you need to apply the specific APAR that's on the slide. And second, the configuration needs to contain the information allow basic outlookup as a false. Otherwise, it doesn't work correctly. But we've been testing this and using it, and it works fine if you follow these rules. I've already mentioned the SAF resource checks. It's possible to either ask directly and use the API for integration for other of your tools and services, or one of the main usage that we have in the Zowe is the gateway/services endpoint, where you get limited information on all the services that are available via the API mediation layer within your infrastructure. The reason is that it's used for convenience by the Zowe CLI. So if you want to, it's possible to use this endpoint together with Zowe CLI to populate your Zowe CLI configuration fully. As for high availability, here you can see how it looks like what I was talking about. So there is a Sysplug distributor that sharing the pores. Then there are the two Zowe's, each of a different LPARs. API gateway is the part of the mediation layer that handles all the requests. And it's communicated with the discovery services that are clustered together across the LPARs. The discovery services are the key parts of the infrastructure that's calling to each other to make sure that they know of all the services that are onboarded on each of the LPARs. Then there are the caching service, which allows to store information and share them across all the LPARs. For the caching service, we support 3 different backends. I would recommend InfiniSpan, but if you feel more comfortable with mainframe technologies, we support vSAM. And apart from that, for the distributed or more distributed world, we support Redis as well. There are some necessary steps that you have to do in order to have this current high capabilities set up, and one of them is a shared file system between the LPARs in the Sysplex. The Zowe instance is running with all the services on each of the LPARs from the same location. You have to have a proper bypass setup or Sysplex distributor setup, and the ZOSMF needs to be in a high availability mode. I'm pointing in a requirement for the ZOSMF high availability mode. We've been testing with the hot backup options. There are other options how to configure ZOSMF, but not all of them has been tested by Zowe at least. The Sysplex configuration is from the version 2 standard part of the Zowe.yaml configuration. If you take a look at the example Zowe.yaml, then in the bottom there is a section HA instances where you specify each of the LPARs, and you can customize the configuration for the specific LPARs there. So if you are running the services on the different ports, or you want to run just some of the services on some of the LPARs and not all of them, or on all LPARs, it's possible to do easily via this customization of this Zowe.yaml HA instances section. Important part for the HA is the caching service. It's again mentioned within the HA instances, or you could just make sure that it's running the same way on all the LPARs. There are free storages, vSAM, Redis, and InfiniSpan. We definitely recommend InfiniSpan as it's part of the caching service. There is no service started. It's easy to operate and it's easy to work with. And it's very performant. Compared to the way we are using vSAM, the performance is really on scales of difference. One of the things that's coming in the next release 2.7 is the distributed identity federation, which means that Zowe API mediation layer will support the OIDC protocol, and as such will allow for the integration with tools like Okta and Active Directory. It's necessary to run the Zowe system services to be able to do so, as we are consulting the ESMs with respect to who the linkage between the identity federation, distributed identity provider on the distributed side and the ESM user on the mainframe side. Ideally, it would lead to having just one set of credentials instead of having multiple ones, like the set for distributed and then different set for mainframe. And that's it from me. Thanks everyone for your patience and for listening. You can give me feedback via this online questionnaire. And now it's time for the questions, if you have any.
Thank you so much. And the whole day today is dedicated to Zowe on this GSE, and not one of the presenters so far, Jakub, has mentioned that it's an award-winning solution, you know, for the DevOps dozen. And you introduce yourself as the leader of it, so congratulations to you. Thank as you. The starter. And the stuff you've covered there on that high availability is quite amazing, because that's what we're all about on the mainframe, having systems that can withstand outages of individual LPARs. It doesn't bring the whole service down, so that's really interesting. There are no questions in the chat right now, but if anyone would like to pop something in the chat, now's your chance. Although I'm sure, Jakub, you're available on social media if people want to connect with you after the event. And
yeah, if you are interested, feel free to either, you can use my email. It's easy. It's jakub.balhara@broadcom.com. Or you can reach out via the OMP Slack. So if you go to the openmainframeproject.org, there is a Slack open community, and I'm available there as well. Or if you have anything or any questions or concerns, there is the github.com/Zowe/community repository where you can create any issues, and I'm closely following them and making sure that we are at the very least taking a look on anything that we learn. On top of that, if you want to give us more feedback, we are having our question of the month on zowe.org. So we would be more than happy if there is any feedback from your side, including the bad one. We just want to get better.
Yeah, you absolutely do. Yeah, so that's fantastic. And I know that the Slack channels for Open Mainframe cover a lot of the things that you've talked about. So that is good. Yeah, you just got lots of congratulations and thanks coming in on the chat, but no questions. So I think you're good. I don't know. Do you have something tomorrow for the Ansible day?
No. I'm joining just for this zero trust architecture.
Cool. Well, thank you very much for an excellent presentation. And the slides are going to be uploaded, so people will be able to get the content. Brilliant job. Thanks, everyone.
So,
Bye.
thanks, everyone. Have a nice day. Enjoy the rest of the conference.
Thanks.